In this video, we are going to begin our midterm review and we'll focus on integrals. So our goals for this day's videos are to do some practice problems, helping to prep for our midterm. Okay, so let's get into a review of integrals. So what are our methods for evaluating integrals? One of the ways is through basic antiderivative rules. So antiderivative rules. So things that I could evaluate easily. So for example, if I had the integral of something like x squared, that's just reverse power rule. That would give me x to the 3 divided by 3 and then plus c. Or as another example, let's say I had the integral of e to the 4x dx. So that's another one that I can do without something more complicated. This antiderivative is 1/4 e to the 4x plus c. Okay, so basic antiderivative rules, that's one way to evaluate an integral. So some integrals will require U-substitution. So that's another technique that we learned. Okay, so number 3 is integration by parts. Integration by parts. And I would say these are the 3 most commonly used techniques that we've seen so far. But there's one other one that's important and I don't want us to forget, which is sometimes we can do integrals by using areas and geometry. So this is only for a special category of integrals. So this is only for definite integrals, because definite integrals correspond to areas. So this is only for definite integrals with simple shapes. They need to be shapes that we can find the area of using geometry formulas. So part of a circle, or a rectangle, or a triangle. Okay, so let's get into an example. So I want to evaluate the following integrals. Alright, so I just moved this first problem down. It looked like when I had copied it here, it kind of got shifted somehow. Okay, so I want to evaluate this integral, and I want to begin by giving you the chance to try this problem on your own first. So pause the video for about 2 minutes to try this question on your own first. It's super important, especially today during our midterm review problems, to really seize this time to try these problems on your own before we talk about them together. Because it's important to practice this skill of trying problems on your own. Ultimately, that's what you're going to be doing on the midterm. You're going to be tackling new problems. So it's good to practice that now. 4, 3, 2, 1, pause the video. Pause it for 2 minutes to try this first. Alrighty, so hopefully you did that. Hopefully you paused it for about 2 minutes to try this. Let's talk about it together now. So 2 minutes probably wasn't enough time to finish the question, and that's okay. I mostly want you to be thinking about what are the key ideas? How can I recognize how to begin, and what might I do after that, even if you didn't quite finish? Okay, so with this integral, we can simplify it first. So with this numerator, for example, I can square that out by doing square root of x plus 4 times itself. And then I would FOIL this or distribute it. Okay, so let's do that. So if we did that, whoops, try an equal sign. What we'd get is we'd get x plus 8 squared x plus 16 on the numerator all over x dx. And now this fraction, I can split it up into 3 fractions. And we'll end up getting the integral of x over x plus 8. And with the square root x, I'm going to rewrite it as x to the 1/2. Because that's going to be helpful in evaluating the antiderivative over x plus 16 over x dx. All right, so I can simplify this a bit. X over x, that's 1. With the next term, the x on the denominator is x to the 1. And if I were to bring that up to the numerator, the exponent becomes negative. So that'll leave me with plus 8x to the negative 1/2. And then 16 over x is already simplified, so we leave that as it is, dx. Now we're ready for this antiderivative. So antiderivative of 1 is x. For the next term, I leave the 8 there, and then that's going to multiply this antiderivative of x to the negative 1/2, and that's reverse power rule. So adding 1 to the power, we'll get x to the 1/2. And when I divide by that new power, if I divide by 1/2, that's the same thing as multiplying by the reciprocal, which is 2. And then antiderivative of 16 over x, that is 16 times ln absolute value of x. This is an indefinite integral, which means it's a general antiderivative, so I need to put a plus c at the end. Okay, I'm going to simplify one step further, because I got x plus 8 times 2 is 16. Let me just rewrite x to the 1/2 as a square root x, although I could definitely keep it as x to the 1/2, plus 16 ln absolute value of x plus c. And that's my answer right there. So this integral I was able to do just through some simplification and basic antiderivative rules. Let's look at another example. So part B, I have this integral. So again, it's really important to seize this opportunity to pause the video and try this on your own. 4, 3, 2, 1. Pause that video for 2 minutes to try this on your own. That may not be enough time to finish the problem, but that's okay. Really believe that the time that you put into these is going to help. All right, so let's start to talk about it together. Okay, so I want to begin with a tip for this question. So the tip is going to be something keeping in mind that we're reviewing here. So the tip is, if in our integral, if you see an expression and its derivative in the integral, and with the derivative it's okay if you see it up to a constant multiple. So if it's off by a constant multiple, that's okay. We can try U-sub. This is often an indicator that U-sub may be helpful. So for this question, if we do U-sub, I noticed that if I let u be the denominator, x to the 4 plus 2x, and then I take its derivative and I write du, the derivative is 4x to the 3rd plus 2, and I have to write a dx at the end. I notice that that is a constant multiple of the numerator. In fact, this is, if I factor out a 2, it's 2 times 2x cubed plus 1. So I see its derivative showing up in my integral, just off by a multiple, which is going to be just fine. Okay, that's one of the indicators that U-sub may have been a good way to go here. So let's isolate dx. We'll get du over 2 times 2x to the 3rd plus 1 equals dx. And now let's substitute in. Okay, so let me zoom it out a little bit. And if I substitute in, we get the integral. The numerator is 2x cubed plus 1 over denominator's u. And then dx is du over 2 times 2x cubed plus 1. I noticed those 2x cubed plus 1's cancel. So what I'm left with then is I can take this 2, pull it out in front, and get 1/2 integral, 1 over u du. And that's an antiderivative we know how to do. This antiderivative is going to be 1/2 times ln absolute value of u plus c. And then because I did this u-sub, I need to substitute back in what u was, because my original integral had the variable x in it. So I need my final answer to have the variable x in it. Okay, so this is 1/2 times ln absolute value, and u is x to the 4th plus 2x. And then I have that plus c, and that's my answer right there. So notice also that when we did this u-sub, I needed this 2x cubed plus 1 term to have been in the numerator. If it had been in the denominator, when I substituted in, it wouldn't have canceled away with this other 2x cubed plus 1. So that was also something that was helpful here. Alrighty, so let's look at one more example in this video. So we have this other integral here. This one's a definite integral. And like before, I want you to begin by pausing the video for 2 minutes to try this question. 4, 3, 2, 1. Pause that video. Pause it for 2 minutes to try this question on your own first. Alright, so hopefully you did that. Hopefully you paused it for about 2 minutes to try this. So let's start to talk about it together. So this question, this is not an integral, so this is not a function I know how to just do the antiderivative of. If you try u-substitution or integration by parts, it turns out they aren't useful. So, but luckily for us, this is something that we know how to graph, or at least we can graph it, maybe even if we've forgotten how to graph it. So we've seen functions like this before. So let's recall what the graph looks like. If I have y equals the square root of 16 minus x squared, this graph is a something. I'd encourage you to pause the video for about 30 seconds to see if you can fill in the blank if you were stuck before. Okay, so I'm going to trust that you did that, that you paused it for about 30 seconds. So I now want to talk about how could we figure out what the graph was if I was stuck, if I was unsure. Well, it involves simplifying this equation. I can square both sides to get rid of the square root. So I'll get y squared equals 16 minus x squared. And if I move the x squared over, we get x squared plus y squared equals 16. And at this point, hopefully I can recognize, oh, wait, this is a circle. This is a circle. In fact, the center of the circle is 0, 0. And the radius of the circle, the number on the right-hand side, is r squared. So r is the square root of 16, which is 4. So this would be, if I were to square both sides and look at that equation, that gives me a circle. It turns out my graph, where I have y equals the square root, is actually just a semicircle. It's not the full thing. This is a semicircle. So why is it a semicircle and not the whole thing? Well, if I look at this, when you take the square root of a number, the output is not going to be negative. So the fact that you are taking a square root implies that the output, and the output is y, implies y, the y values, are non-negative. Are non-negative. And that means when I go to draw this graph, let's scroll it down. So when we go to draw this graph, we are only going to draw the top half of the circle. Okay, so I'm going to draw some tick marks. So this is the top half of the circle centered at the origin, and its radius is 4. Okay, so up here on the y-axis also reaches 4. And for my integral here, I just care about finding the area from x is -4 to x is 0. So that is this part of this semicircle. Overall, that is a quarter of a circle. So the area of a quarter of a circle is 1/4 pi r squared. And if I plug in the radius, I get 1/4 pi. The radius of this circle is 4. So 4 squared. And one of the 4's are going to cancel. So I will end up with 4 pi. And that's my answer. Alrighty. So that is it for this video reviewing integrals. In the next video, we are going to review marginal cost / revenue / profit by looking at an example.